In the United States today, we spend hundreds of millions of dollars on precision computing, communicating, and networking equipment. The lifeblood of the performance in that equipment is stable, reliable, available source voltage. In the next 3 to 5 minutes, we are going to demonstrate a dramatic difference in UPS output and the ability to deliver rock solid, stable, clean output voltage. Let's describe our equipment. Today we have two conventional tower UPSs, both of the same power, 1 kVA, 700 watts. Two different topologies. This unit is an industry standard. It's probably one of the most popular UPSs on the market today within the line interactive category. On my left, we have the Sanyo Denki America, SANUPS, A11H, or known as SANUPS A. This is a true online double conversion UPS. Today, we're going to challenge both of these units with 4 standard power conditions: voltage drift, voltage spike, voltage sag, and voltage collapse. Let's see how our two units compare. We're using a variable transformer to simulate utility source voltage. The output of this variable transformer is connected to both UPSs. Both UPSs are seeing identical voltage in this demonstration. This meter is indicating utility voltage. This meter is connected directly to the line interactive output. This is the voltage that your precision equipment is experiencing and seeing. Let's go into a drift. The first most common symptom of the line interactive UPS is the one-to-one relationship of output voltage to utility voltage. You can see as utility voltage changes, so does your output. Let's go into the spike. As our voltage climbs, you're going to hear a click. What just kicked in is an automatic voltage regulator. It's the best this unit can do to protect the power quality level of the output. And now we're at 142 volts. Our output is at 126 volts. But what has taken place is we've had an electrical event called the AVR. Let's drop back. Let's spike up again. Let's continue on and let's demonstrate a sag. Now our utility continues on close to the 100 volts, down into the 90s, and again our AVR is kicking in. We're going to drift, and then the utility decides to collapse. So we get down to a very common voltage level, about 84, 85 volts. Now we're into a full battery event. Your batteries have taken over, your power is restored, but this unit right now is leading to one of the largest expenses in single-phase UPS, the battery purchase. People buy pallets of batteries in protecting the UPS from this event right here. You don't hear it, you don't see it because it's stuffed in a closet. But the fact is, battery replacement represents the highest cost of operating drawback of the line interactive UPS today. Let's see how our true online double conversion performs in this environment. Once again, utility voltage, this is your precision voltage output that your equipment is seeing. Let's go into our drift condition here. As we begin to drift, we begin to see a voltage drift. You hear a familiar clicking and beeping? That's our friend, the line interactive UPS, trying to maintain power quality. Please notice the output voltage. Has it moved? I can't see it, but I bet you it hasn't. Let's go for the spike. As our voltage climbs, notice the output voltage of the true online double conversion. It's extraordinary. Here we sit, 143 volts. Let's come down off of that. Let's go back up. Let's sit at the spike a little bit. Let's visit that spike a couple of times. All right, we have high instability in the utility today. Let's go down into a sag condition. As we get down into our sag condition, please notice our output voltage. Now we collapse. This unit is rated for 55 to 150 volts of online performance. There we are, 55 volts. Has there been any change? Just for the fun of it, let's have a little fun with this. Let's go back up to a spike. Now let's collapse it again. Let's go back to a spike. Has your equipment seen 1 volt of this transition? It hasn't. For all the engineers and technical people, we have captured this very demonstration graphically on a Fluke Power Analyzer. This graphic depicts voltage stability over the course of time. Your equipment deserves it. Your equipment demands it. Consider Sanyo Denki America SANUPS model A11H, the best power quality available on the market today.